8, that is 8 x tan inverse x dx. Again the same uh, thing, that is inverse is your first function, algebra is your second function. So let us do the integration. Tan inverse x, this is the first function, x dx, minus integration differentiation of first function and then integration of second function bracket close dx. So here you see that this is x square by 2 tan inverse x, and differentiation of tan inverse x is 1 plus x square, and this is x square by 2 dx. So now here x square by 2 tan inverse x minus 1 by 2, this will be x square by 1 plus x square dx. Again I am going to solve this. I am going to do a little bit of adjustment. The adjustment is x square by 2 tan inverse x minus 1 by 2. This is 1 plus x square minus 1 by 1 plus x square dx. So here you see that the 1 and 1 cancel out. So there is no alteration in the question. The question remains as it is. But there will be a profit for me to solve this question. You can see here, this is 2 tan inverse x minus 1 by 2, 1 plus x square by 1 plus x square dx minus dx by 1 plus x square, and this is all. So here this cancels out, and x square by 2 tan inverse x minus 1 by 2, this is integration dx, and this is tan inverse x, and now I am going to do further, that is x square by 2 tan inverse x minus 1 by 2 x minus tan inverse x plus c, some integration constant. So this will be x square by 2 tan inverse x minus x by 2 plus tan inverse x by 2 plus c. So here you can do this common simplification. This will be x square plus 1 by 2 tan inverse x minus x by 2 plus c. So this will be your answer, and let me check the answer. That is question number 8, 7.6, 7.6, 7.6, question number 8. Here they have done that, they have kept this answer here itself. There is no problem here. You can take tan inverse x common and x square plus, but in this they have kept the answer here itself. In your book the answer has been kept here, but you can do this also, there is no problem. So now I am going to question number 9. See here, your question number 9 will be same as question number 7 which I did you earlier, that is x sine inverse x. Here you can see that your question number 9, that is question number 9, that is integration of x cos inverse x dx. This will adjustment, everything will follow the same procedure which I have already done in question number 7, that is x sine inverse x dx. This will follow the same procedure as I have done in earlier, same adjustment, everything will be same. So I think so you can do it. I am going to the next question, that is question number 10. Here question number 10. In question number 10, that is integration of sine inverse x square dx. So here you see that what is the problem here? That is, there is no two function sine inverse x squared dx, but we have to integrate it. So I am considering this is inverse, you all know, and dx as the algebra. I am considering this as inverse and dx as the algebra. So to integrate it, let me move like this. That means inverse, first function sine inverse x the whole square integration of dx minus integration differentiation of sine inverse x the whole square integration of dx. So now here you see this will be x sine inverse x the whole square minus, here again there will be chain rule. So according to the chain rule, it will be 2 sine inverse x, and differentiation of sine inverse x will be root over 1 minus x square, and this will be x dx. So this comes out to be like this, sine inverse x the whole square minus 2 constant outside sine inverse x by root 1 minus x square dx. So here you see, again here you see a problem has come forward. So how I am going to solve this part? So to solve it, here you see integration of x sine inverse x root over 1 minus x square dx. Now I have to solve it. How I am going to solve it? You can see here. So here let sine inverse x, I am going to take the help of substitution method, which I have discussed earlier. So differentiation of sine inverse x will be root over 1 minus x square dx is equal to dt, and the value of x will be x is equal to sine t. So now this get reduced to, here this you see, this is your dt and x is sine t. So this reduced to t sine t dt. Now I am again going to apply the ILAT rule, your ILATE rule. According to it, here you see your t is algebra and sine, this is trigonometry. So algebra is the first function. So t integration of sine t dt minus integration differentiation of this and sine t dt, dt bracket close dt. So here this will be t minus sine, this will be t minus cos t, and this is 1, the sine t will be minus cos t dt. So minus t cos t plus integration of cos t dt. So this will be minus t cos t, this will be plus sine t. Now here, because we have taken sine inverse x is equal to t, so here I am going to do this like this, minus t cos t, you all know this is equal to 1 minus sine square t plus sine t. This is cos t, because cos square theta plus sine square theta is equal to 1. So it becomes easy for me to place here, instead of t it will be minus sine inverse x and root over 1 minus sine t, this is x square, and then sine t, this is x. So this integration of this, I am going to get this, I have got this result. So this result I am going to place here. So this will be x sine inverse x the whole square minus 2 minus sine inverse x root 1 minus x square plus x plus c integration constant. So this is x sine inverse x the whole square plus 2 sine inverse x root 1 minus x square minus 2x plus c, or let me write it like this: x sine inverse x the whole square plus 2 root 1 minus x square sine inverse x minus 2x plus c. So this is your answer. So let me check the answer. That is question number 10. Let me check it. 7.6, 7.6 again. Question number 10. This is answer is correct. So here now I am going to question number 12. So see question number 12, 11. Next question is question number 11. So I think so you have understood it, how to solve this and what are the techniques has been applied, and do not be nervous while solving it, because there are many alternatives to solve the problem. Now question number 11, that is here integration of x cos inverse x by root over 1 minus x square dx. So again, to solve this I am going to take the help of this substitution method. So here what I am going to do is that I am going to take, let cos inverse x that is equal to t, when I differentiate it with respect to x, I am going to get minus 1 by root over 1 minus x square dx is equal to dt, and here x is equal to cos t. So you can see this. Now I am going to place all this thing here. So x will be your cos t and cos inverse x will be your t, and dx by this will be equal to minus dt. So here this is your result. I have reduced it to this form, and now there are two functions, so I can integrate it by parts and I will apply the ILAT rule. So according to it, your t is your algebra and cos t is your trigonometry. So algebra, this is your first function, minus I have kept here t cos t dt minus integration differentiation of first function and integration of second function dt close curly bracket close dt. This is curly bracket close. So here you see this will be minus t minus bracket t, this will be sine t minus this will be 1 cos t, that is sine t, and then dt. This is, now I am going to integrate it further, t sine t minus integration of sine, that is minus cos t and plus c. So here this comes out to be minus t sine t plus cos t plus c. Now since we have taken cos inverse x is equal to t, so for this t I am going to write it as 1 minus cos square t plus cos t and plus c. So here you see your t is cos inverse x, this is 1 minus x square, 1 minus x square cos inverse x, your this is x plus c. So this is your answer. So let me check the answer of question number 11, 7.6, 7.6, question number 11. The answer is correct. here this is minus, so it is minus only, because here you see minus cos t, that is into cos t is sin t, and again here they have not given the bracket, so minus, this is correct only after all, because there must be a bracket here, so they have not given the bracket. Let me check it once again. That is the, here this is minus t, so cos integration of cos t is sin t, and here again sin t, but integration of sin t is minus cos t, so this is your integration of cos t, it is minus sin t, so, and again sin t, integration of sin t, it is minus cos t, so minus minus this becomes plus, so here answer is correct. This will be the answer. Now, because here most probably in printing here, when the answer is given here, while printing the bracket they have missed it, so they have written minus, they have written a little bit far apart, so this shows that there was a bracket which they have missed while printing it. So this is all, I think so this is fully correct. It is correct, because here this is minus d, this is minus dt, and now here this will be cos, that is integration of cos t is sin t, and this is 1, and cosine t into cos t minus, and this is correct after all. Now I am going to question number 12. Here you see I am going to question number 12. In question number 12, here again this is integration of x sec square x dx. So here again you see x is your algebra and sec is your trigonometry. So algebra is your first function, x integration of sec square x dx minus differentiation of first function, integration of second function, and then close curly bracket close dx. So x integration of sec square x, this is 10x, you all know that, and this is 1, and instead of sec square x this is 10x and dx. Now x 10x and integration of 10x, it is log sec x plus c. This is your answer. So let me check the answer of question number 12. Question number 12, 7.6. Question number 12. Question number 12. Here they have written cos x. This can be done. This is x 10x minus log sec means 1 by cos x plus c. So x 10x minus log cos x to the power of minus 1 plus c. So this will be x 10x and this will be plus log cos x plus c. This can be manipulated. So I have the answer. I have further done the further correct simplification, and this is the answer is correct. Now I am going to question number 13. Now question number 13, here you see question number 13. Question number 13, it is integration of tan inverse x dx. So here you see there is only at the first sight it looks that there is only one function, but we know that there is no integration of, there is no formula for integration of tan inverse x. So I am going to take the help of the integration by parts. I am considering dx as algebra. So inverse, this is the first one. Inverse comes before algebra. So inverse will be the first function which comes before such I and L. Since I comes before L, so I will be the first function. Similarly, I comes before A, so I inverse will be the first function. So, and we will treat dx as algebra. So this will be tan inverse x integration dx minus differentiation of tan inverse x and uh, integration of second function closed dx. So this will be x tan inverse x minus differentiation of tan inverse x will be 1 plus x square into x and then dx, because integration of dx is x. Now here x tan inverse x minus x by 1 plus x square dx, here there is no problem because differentiation of the denominator is present in the numerator. Differentiation of denominator, this is one constant is 0 and 2x, so 2 is required, so I am going to do like this. So now everything is clear. X tan inverse x minus 1 by 2 log 1 plus x square plus c. So this is your answer. So let me check the answer here. Question number 13. Let me check the answer. 7.6, question number 13. Your answer is correct. Now I am going to question number 14. Here you see question number 14. So question number 14 here is integration of x log x the whole square dx. So how to integrate it? Again same thing, x will be considered as algebra and log will be logarithmic function. Since log comes before algebra, so log will be treated as the first function. So let us move forward, that is log x the whole square integration of x dx minus integration differentiation of first function, that is log x the whole square integration of x dx and then dx. So here this will be x square by 2 log x the whole square. This here there will be chain rule, so according to chain rule this will be 2 log x and differentiation of log x will be 1 by x and this will be x square by 2 dx. So 2 cancel out, so this becomes x square by 2 log x the whole square minus this will be x log x dx. So again here there are two functions, so again I am going to apply integration by parts, the same rule. So log will be your first function and algebra will be your second function. So this comes out to be x square by 2 log x the whole square minus, so your log, it is your first function, log x integration of x dx minus integration differentiation of log x and then integration of x dx. So this is dx and big bracket close. So here this is x square by 2, so this is log x the whole square minus, so this will be x square by 2 log x and this will be 1 by x and this is x square by 2 dx. Now again here this will be x square by 2, this is log x the whole square minus this will be x square by 2 log x and here one x cancels out, here remains x dx. So this is all. So further x square by 2, this is log x the whole square minus this is x square by 2, this will be log x minus 1 by 2, this is x square by 2 and then integration constant. I am going to open the bracket, so this will be x square by 2, this will be log x the whole square and here this will be x square by 2 log x and plus x square by 4 plus c. So this is your answer. So now let us check 7.6, question number 14. 7.6, 7.6, 7.6, question number 14. Here answer is correct. Now I am going to question number 15. Here you see I am going to question number 15. For question number, I am going to question number 15. Here, this is integration of x square plus 1 log x dx. This is question number 15. So how to solve it? Well, let us take this as algebra and this is as log function. So log, it will be, log is before algebra, so log is your first function. Log x integration of x square plus 1 dx minus integration differentiation of first function and again integration of your second function and then closed dx. So here this will be log x and integration of this will be x cube by 3 plus x, and here this will be 1 by x, and integration of this will be x cube by 3 plus x and dx. So here you see this will be x plus x, let me write like this. This will be x cube by 3 plus x log x minus, here when this enters into the bracket, that is distributive law, here we are going to get x square by 3 plus 1 dx. So this will be x3 by 3 plus x log x minus, this will be x square by 3 dx integration plus dx. Now this will be x cube by 3 plus x log x, and this will be 1 by 3 x3 by, let me write, this will be x3 by 3 plus x plus c. So this comes out to be x cube by 3 plus x log x, this is log x, minus x cube by 9 minus x plus c. So this is your answer. So let me check the answer. 7.6, 7.6, your 7.6, question number 15, answer is correct. Now I am going to question number 16 here. Now I am going to question number 16. So question number 16 you see. The next question is question number 16, that is e to the power of x sin x plus cos x dx. So here see how I am going to solve it, making it into two parts, sin x dx plus e to the power of x cos x dx. Now what I am going to do here, that only I am going to integrate any one of these two. You can select any one of these two and the other one will be kept, I will keep it as it is. So I am going to keep this one as it is. I am going to integrate this by the help of parts. So exponential and trigonometry, since trigonometry comes before exponential, so trigonometry will be considered as first function. So this will be sin x e to the power of x dx minus differentiation of sin x, again integration of e to the power of x dx and dx, and this will remain as it is cos x dx. This will remain as it is. So here you see that this is e to the power of x sin x minus differentiation of sin x is cos x, and e to the power of x then dx plus e to the power of x cos x dx. Here you see these two cancels out, so the answer remains e to the power of x sin x plus c. This is your answer. So let me check it. Check the answer. 7.6 7.6, question number 16. This is answer is correct. Now I am going to question number 17. See question number 17. Question number 17, I am going to do this for you. That is 17. Integration of x e to the power of x by 1 plus x the whole square dx. So here you see how to integrate it. Here you see I am going to do one thing here, that is 1 plus x minus 1 e to the power of x 1 plus x the whole square dx. Always my objective is that to remove the denominator or to minimize it as much as possible. So here you see this can be divided into two parts, 1 plus x e to the power of x by 1 plus x the whole square dx minus e to the power of x 1 plus x the whole square dx. So here you see this and this cancels out, e to the power of x by 1 plus x dx minus e to the power of x 1 plus x the whole square dx. So what I am going to do here, that is I am going to keep this as it is, and only thing I am going to do is that is I am going to integrate it. So here 1 by 1 plus x is considered as algebra and e to the power of x as exponential. So algebra will be your first function, 1 by 1 plus x and e to the power of x dx minus differentiation of dx 1 plus x to the power of minus 1 integration of e to the power of dx and close dx, and this will remain as it is, e to the power of x by 1 plus x the whole square dx. Now here you see this will be e to the power of x by 1 plus x minus this will be minus 1 plus x to the power of minus 2 e to the power of x dx and minus e to the power of x by 1 plus x the whole square dx. So this comes out to be e to the power of x by 1 plus x plus e to the power of x by 1 plus x the whole square dx minus e to the power of x by 1 plus x the whole square dx, and this cancels out. So your answer will be e to the power of x by 1 plus x plus c. So this is your answer. So let me check it. Question number 17. Let me check the answer. 7.6. 7.6. Question number 17. This is your answer. Answer is correct. Now I am going to question number 18. So see here question number 18. How to solve question number 18. So you see that here the question is 18. Integration of e to the power of x 1 plus sin x by 1 plus cos x dx. Now how to solve it? So here there is a problem which is coming forward. So to solve it, let me simplify first this what comes out. So you know that 1 plus sine x by 1 plus cos x, this is uh, cos square x by 2 plus sine square x by 2 plus 2 sine x by 2 into cos x by 2, because one can be written as like this. This one is cos square theta plus sine square theta, and sine x is 2 sine x by 2 cos x by 2 by 1. This can be written as cos square cos this can be written as cos square x by 2 plus sine square x by 2, and cos x, this is cos square x by 2 minus sine square x by 2. So here in the denominator, sine square x by 2 sine square cancels out. So in the numerator it becomes cos x by 2 plus sine x by 2 the whole square, and here this is 2 cos square x by 2. So further what I can do is that 1 by 2 I have kept keeping outside. So this will be cos x by 2 plus sine x by 2 by cos x by 2 the whole square. So now this can be further simplified as 1 plus 10 x by 2 the whole square. So this whole thing is simplified in this form. So this is e to the power of x, 1 by 2 constant outside, 1 plus 10 x by 2 the whole square dx. So this is square, this is giving us the problem. So let us open it. 1 by 2, this will be integration of e to the power of x, 1 plus 2 10 x by 2 plus 10 square x by 2 dx. So this will be 1 by 2 e to the power of x dx plus 2 e to the power of x 10 x by 2 plus dx plus e to the power of x 10 square x by 2 dx. So now here for these two terms, if this is 10, this will be trigonometry and exponential. Trigonometry will first function, and if I differentiate 10, I am going to get 6 square x by 2. So most probably I am going to keep this as it is. I am only going to integrate this. So let us see what happens if I integrate this. What is the result? Let me see. So here you see that I am going to integrate this. Integration of e to the power of x, e to the power of 10 x by 2 dx. So here your trigonometry is the first function. So 10 x by 2 x dx minus integration differentiation of 10 x by 2 integration of e to the power of x dx. So here what do we find here? We find that e to the power of x 10 x by 2 minus differentiation of 10 x by 2, this will be constant will come forward, and 10x, that is 6 square x. So this will be 1 by 2 6 square x by 2 e to the power of x dx. So now here again e to the power of x 10 x by 2 minus 1 by 2, I can write instead of 6 square x 1 plus 10 square x by 2 e to the power of x dx. So here again this will be e to the power of x 10 x by 2 minus 1 by 2 e to the power of x dx minus 1 by 2 e to the power of x 10 square x by 2 dx. So this is the result I have obtained here. So I am going to place this result, this result here. So this will be 1 by 2 e to the power of x dx plus 2, and this will comes out to be your e to the power of x 10 x by 2 minus 1 by 2 e to the power of x dx minus 1 by 2 integration e to the power of x 10 square x by 2 dx bracket close and plus e to the power of x 10 square x by 2 dx. So now here you see 1 by 2, this will be 1 by 2 this will be e to the power of x plus 2 e to the power of x 10 x by 2, and this will be minus 2 cancels out, so this will be e to the power of x, and again minus e to the power of x 10 square x by 2 dx plus e to the power of x 10 square x by 2 dx bracket close. Here you see that these two terms cancel out, this also cancels out, so the only answer remains is e to the power of x 10 x by 2 plus c. This is your answer. So let me check the answer. 7.6, your question number 18. 7.6 question number 7.6 question number 18. The answer is correct. Now I am going to question number 19. So question number 19 here, you see how to do it. Question number 19, that is again question number 19, e to the power of x 1 by x minus 1 by x square, so integration dx. Again what I am going to do I am going to divide into two parts, that is by x dx minus e to the power of x by x square dx. Here I am not going to disturb this, I am going to only disturb this one. So exponential and algebra, your algebra will be your first function 1 by x e to the power of x dx minus your differentiation of dx x to the power of minus 1 e to the power of integration e to the power of x dx bracket close dx minus e to the power of x dx by x square. So this will be e to the power of x by x, and this will comes out to be minus 1 x to the power of minus 2 e to the power of x dx minus e to the power of x dx by x square. Here you see this plus and this terms cancels out, so only your e to the power of x by x plus c, this remains. This is your answer. So let me check the answer. Question number 17.6. 17.6. Your question number this is 19, e to the power of x by x plus c. This is correct.